Hi folks, this is Nikhil and you are learning GoLang with me. So in the last video we have seen how to declare any variable in GoLang. Either you can make use of the shorthand operator or you can make use of the var operator. And I have already explained what is the difference between the var and the shorthand operator, and then what are the rules to either make use of the var in GoLang program or make use of the shorthand operator in the GoLang program. So just to revise, if you are using the variable inside the method and that's the scope of the variable, and then you do not want to make use of the zero value of the variable, then just go ahead and make use of the shorthand operator. So you over there you don't have to worry about the data type, you can directly assign the value. But once you assign the value, GoLang compiler inferences the data type of that variable, and then as it is statically data type, you cannot really change the data type of that variable. So for example, if you have int like this example, so x will get the int as the data type, then you cannot assign the string value to the variable. And then if your variable is declared with the var, then the scope of this variable is the entire package, and then automatically once you declare the variable with the data type, then automatically the zero value is also gets assigned to the variable until you assign an explicit value to the variable. For example, if I have the global var as int and the global var string as string, then default value that the global var will get is 0, and default value that the global var string will get is empty string. So let's elaborate this topic further. So now I just want to talk about the primitive data types in detail. So if you navigate to this Bible of GoLang, which is nothing but the spec of GoLang, then you will find that there are primitive data types and the composite data type. So like any other programming language, the primitive data types consist of boolean types. So boolean type represents the set of boolean truth values denoted by the pre-declared constants true and false. So if you have any variable having this data type, then only two values are allowed, true and false. Then the numeric types such as int or float. So in GoLang there is no long as such, because instead of long like a Java language or Scala, you don't have the long in GoLang. Instead of that, you have the different buckets of the integers. So you start with the uint 8, uint 16, uint 32, uint 64. Then you have the regular int 8, int 16, int 32 and int 64. So before we proceed, let me just focus on the uint versus int. So those who are experienced developers might have understood what is the difference between the uint 8 and the int 8, because both of them represent the 8-bit integers, but there is a subtle difference in both of them. In uint 8 you have the unsigned 8-bit integer, whereas in int 8 you have the signed 8-bit integer. That's the huge difference, because in unsigned you are not counting the negative numbers, you are counting the numbers from 0 to 255. So 2 to the power of 8 is 256, but you start from 0 in case of the natural numbers, and that's why the count ends at 255. However, in int 8 you start with the minus 128, that is the negative numbers of the natural numbers bucket. So you start with the negative 128, and that's why the count ends at 127. Similarly, if it is uint 16, then it starts from 0 and 2 to the power of 16, which is 65536, but as we are starting from 0, the count ends at 65535. And like the int of the Java, the int 16 starts from minus or the negative 32768 and ends at 32767, which is positive number. Like long in Java, int 64 starts with this negative number, which is, I will say, minus 2 raised to the 32 and ends at 2 raised to the 32 minus 1. So that's why, because we have the int 64 and uint 64 in GoLang, you don't see long data type. So long does exist in GoLang, but it is represented by int 64. Then you have the float 32, float 64, the set of all IEEE 754 32-bit floating point number or 64-bit floating point number. So depending upon the architecture of your processor, either you have the 32-bit processor or 64-bit processor, and then yes, in the embedded systems world, you have processors with different bits, but we are not considering them over here because the programming languages used in the embedded systems world are different. Okay, then you have the complex 64, complex 128, which also deals with the imaginary numbers, and then you have the byte. I believe that most of you are familiar with byte, so it is nothing but the alias for uint 8, which is this one, and then you have the rune, which is an alias for int 32. So that is for the numeric types. So I have discussed about numeric types in detail. Then you have the string type, which is a regular string in which you have the representation of the set of the string values. A string value is a sequence of the bytes, and the number of bytes is called the length of the string, and it is never negative. And then, like Java, the strings are immutable, which means that once created, it is impossible to change the contents of a string. Now we are going to use all of this knowledge by doing a small program, because unless and until you do some kind of hands-on activity, the knowledge does not really get imbibed into that. So let's get started. So I start with the simple application. I will say that it's primitive data type in or let's say primitive data type demo, and then let me just get started with the var and assign the true, and then fmd.println the value of var is var. Okay, and then let me just format the code. Okay, so let me just add the comment as well. Declare a variable and assign value true to it. Okay, so let me just go ahead and assign, let's say 10 to this, just to demonstrate that I should get the compiler error. So now over here you can see that cannot use 10, which is of type int, as type bool in assignment. So you can see that once you declare a variable and once the compiler inferences the data type, then you cannot really assign any other value which belongs to the other data type to the same variable. I can only assign false or true to this variable. So let me just demonstrate that. Okay, what is I need to make use of the equal to operator, that's it. So now we declare a variable of bool type, and then we change the value change value to false. Okay, that's it. Okay, so let's get let's run it, and then you can see it is true or false. Then declare a variable of type in for demo purpose, let me just say uint 32 and int 32. I just want to demonstrate the difference in between them. So let's say I use var, I use var uint var, and it's of type uint 32. I have to be consistent in the comments, and then var int var of type int 32, and then assign the extreme left value and right value to the int variables. I will say uint uint var variable and int var variable. So if I just go back to the Bible, then the extreme left value of uint 32 is 0, and extreme left value of int 32 is minus 2147483648. Very small number, you know. So uint 32, and let me just copy this value. I cannot memorize that value, to be very honest with you, and then I should get the error, because I should get the error as it's uint 32, and let me just use it somewhere. So the value of uint var is, and int var is, okay. So let's run this, and then you can see that there is a runtime error that constant minus 2147483648 overflows uint 32. So I need to change it to the 0. The extreme left value of, okay, and then the extreme right, so extreme left value of, okay, cool. And then in this you can see that if I use the extreme negative value, which is this one, I'm allowed to do so because it is of type int 32. So you can see that the rules are getting followed. Then let me just go ahead and do the similar kind of operation for the right extreme value, which is this one in case of uint 32, and this one in case of int 32. constant. Oh, I need to reduce it by 1. Okay, cool. So we have seen bool, we have seen integer. So let's also see the float 32 or float 64. So declare a variable with float. So that's it in this video. Of type float 32 and float. So I need to say declare variables of type float 32 and float 64. So if I just go back to the Bible, then you can see that float 32, float 64, and then represents all 32-bit floating point numbers and then 64-bit floating point numbers. So let me just say that this is my float 32 var, and it's of type, let's see, var float 32, and it's of type float 32, and var float 64, var float 64, and let's say I just want to assign 100 point some fraction, and over here let's say this is minus 19.012, and then I just wanna print them. I have to use them somewhere. So strip typo, let me just rectify the mistake. Okay, then let me just change it. You have to be extremely cautious when you do the copy paste in the programming. Otherwise, if you are not cautious, then you get caught in the code review. Okay, so the value of float 32 var is this one, and the value of float 64 is this one. So let's run it. You can see that my fractions are getting intact, so they are intact. So if I use something like something long fraction like this, then you should see that in the float 32 my fraction part towards the end is getting dropped. Why? Because it's float 32. So that's why you can see that you have the 1 2 3 4 5 6 7 8 9 10. So over here you can see that after this 033 my remaining fractional part is getting dropped. So if I use the similar value in the float 64, then you will see that all of my fractional part is intact, and that's the main difference between float 32 and float 64, which represents the difference between the 32-bit processor or 32-bit architecture versus 64-bit architecture. Okay, cool. So now we have also covered the float 32 and float 64. I'm not going to talk about the complex numbers, because complex numbers are not really common in day-to-day use cases. At least in my work, I've never used a complex number. So let's jump on to string. So I just wanna declare a variable of type string. Okay, and represent the string in bytes as well. Oh, wait a second. What I just typed? Represent the string in bytes? Why? Because if you remember, a string type represents a set of string values, and a string value is nothing but a sequence of bytes. So that's why I want to represent string in bytes. So let me just declare variable let's say string var. You can see that I'm following the consistency. Bool var, uint var, and oh, there is a typo by the way. Okay, so let me just change it. Okay, var string var of type string, and I assign the value I love GoLang programming, which is true in this context. And then I want to, or I'll have to make use of it. So I will say that okay, the value of string var is, you can see that I love GoLang programming. Now I have already said that I wanna represent the string in bytes, so I will just go ahead. I will declare var. Let's say this is my byte var of string, and then I will say it is of byte, and then byte, or let me just directly go and assign let's say my byte and string var. I should get the error because it's the array of bytes, so let me just use it. What is the error? Cannot convert expression of type string to the byte. Okay, so like this. Now I need to make use of it somewhere, so print ln, and then you will see a surprise. You will get a surprise. So byte representation of my string is this one. Okay, so byte var of string, or let's say I will use printf for this. Byte representation of my string person as byte representation let's keep the thing simple. So my string of the string is this one. Okay, so let's see what is that. Oh, what is that? There is the array. I know that it has to be the array because the Bible says that it is a sequence of bytes. But what is this? 73, 32, 108, 111. What could be this? Let me just think about it. Why don't we just take a pause and think about it, and then post your answers in the comment. Let's see whether you have some kind of understanding about how the strings are represented. Okay, I hope that you have figured this out. Let me just kill the suspense. This is nothing but the sequence of byte, and these individual numbers are nothing but the ASCII representation of your characters. So capital I, the ASCII value is 73, small l, the ASCII value is 32. So if I just go to the table, ASCII table for characters, then you will find that my I is 73 in decimal. So this is 73. My L, small l, where is that? So L represents 108, and somewhere over here there has to be the empty space. Let me just say, okay, space 32 decimal. Okay, and then what is the last? 103. So if I just go to the table, 103, 103, 103, 103, which represents small g. So you can see that this is the g. Okay, so that's it for string. So we covered bool, or boolean, we covered numeric types. We also seen what is the difference between the unsigned integer and signed integer. Then we have seen the difference between the floating point representations in GoLang, float 32 and float 64. And finally, we have also seen very sedulously how to declare the string variable and then how to represent that in the bytes. That's it for this time. See you in the next session.